In this example, we're going to look at how to calculate the results of a titration using the titration formula. So the titration formula is really something that is set up to equate the moles of H plus ions in a solution with the moles of OH minus ions, because we know that different amounts of acids and bases will supply different amounts of H plus or OH minus based on their stoichiometry. So in this question we are asked, what volume of 0.1 molar HCl will neutralize 1 liter of 0.9 molar barium hydroxide? So since we can see some language there about, I was going to say the will neutralize, that part, that's how you can know that it's a titration or a complete neutralization problem and not like a partial neutralization problem, which we'll be looking at later. So you can know that we're going to be using the formula Na times Ma times Va equals Nb times Mb times Vb. So this is the quantity of hydrogen ions per molecule supplied by the acid. This is the molarity of the acid. Va is the volume of the acid. Nb is the quantity of hydroxide ions per molecule supplied by the base. The Mb is the molarity of the base. And the Vb is the volume of the base. So again, keep in mind, I'm just going to write this here. Na and Nb are not the same as the actual moles of acid or base, right? They are moles of H plus and OH minus. It's very, very important to keep that in mind because we have to remember our stoich. So I would say that our next step here, now that we've identified the formula we're going to use and we've double checked some of the logic behind using it, we're just going to set up a data list. So we know that we can start to put together some of this information. So we know Na is going to be part of it. I'm just going to list out all the variables and we can fill them in as we go. Alright, so we know that the volume of the base is 1 liter. We know the molarity of the base is 0.9 molars. The volume of the acid is the unknown. The molarity of the acid is 0.1 molar. And now determining Na and Nb is very similar to a previous example video that we watched where we looked at how many hydrogen ions are produced from the ionization of sulfuric acid. So we're just going to write the ionization and dissociation equations really quickly for HCl and barium hydroxide. So HCl, we know that that's going to make 1 H plus and 1 Cl minus. And then barium hydroxide, we know that's going to make 1 barium 2 plus. Again, charges are from the common ionic states of the elements. And 2 OH minus. And we know that there's 2 OH minus because there's a subscript of 2 right there. So that means that Na is going to be 1 mole, right? Because there's 1. And then the Nb, or the moles of hydroxide, is going to be 2 moles. Alright, so our next step is just going to be to perform algebra on this main formula to isolate the variable that we want to solve for, and we want Va. So if we know that Na times Ma times Va equals Nb times MB times VB. We can divide both sides of the equation by Na times Ma, and we'll get the volume of the acid on its own. So that's going to give us Va equals Nb times Mb times Vb divided by Na times Ma. And then it's just a matter of subbing in all of our variables. So we'll go back to our data list, make sure that we know what we put down. We know that there were 2 moles of hydroxide ions supplied by the base, so 2 moles there. The molarity of the base is 0.9 molar. The volume of the base was 1 liter, divided by, there was 1 mole of H plus supplied by each molecule of acid, so 1 mole there, times 0.1 molar was the molarity of the acid. And then we're just going to type all of that into our calculator. And when you do that, it will return a value of 18 liters, approximately. So you should get like 18 liters. So 18 liters is the approximate amount through our estimation of how much HCl would be required to neutralize that given amount of barium hydroxide. So therefore, 18 liters of hydrochloric acid are required to neutralize 1 liter of 0.9 molar barium hydroxide. So just to recap there, we knew that this was a titration question or a complete neutralization because the question said will neutralize. It said that up top. So we know that we can use that formula to solve it. We wrote the ionization and dissociation equations of both the acid and the base to see how many moles of hydrogen and hydroxide ions they would each respectively produce, just to double check that it might not necessarily be a 1-to-1 ratio, which it was not because of the hydroxide. Then we went to our data list and we inputted all of our information to make it easier on ourselves to solve later. Then we performed algebra for the equation to isolate the volume of the acid on its own. Then we plugged in our numbers and we got a final answer of 18 liters. So that is how you approach those titration type problems or complete neutralization problems.